Hi, welcome to our next level 3 video on trigonometry. We're going to look at some trigonometric graphs now. And the first thing we're going to do is go back and look at the very basic functions for sine, cosine and tan. So we've got sine, y equals sine x. We've got the cosine graph, y equals cos x. And we've got the tan graph, which is short for tangent, y equals tan x. So let's start off with our y equal to sine x. Here's what the y equals sine x function looks like. Now let me remove it for a second and see if we can plot some points. Now we're working in degrees at this stage, so let's take the sine of negative 90 and we get negative 1. So we have a point here at negative 90 comma negative 1. When I go sine of 0, I get 0, which is the origin. When I go sine of 90, I get 1, so we're at 90 comma 1. When I go to sine of 180, we're back down to 0. And when I go to sine of 270, we've dropped back down to negative 1. And if I go sine of 360, I'm back to 0. So here are a few of the points that make up the graph y equals sine x. Right, now a couple of features you need to be familiar with. The graph does not go greater than 1 or less than negative 1. And we're going to talk later on in an upcoming video about this word called the amplitude. The amplitude of y equal to sine x is 1. Right, well the sine graph passes through the origin at the point 0, 0. And you can see that the sine graph is made up of a repeating pattern, starting at 0, 0 and finishing at 360. So we refer to this as the period, and we're going to again talk about this feature more in an upcoming video, but the period of the sine graph is 360 degrees. Now we could redraw this graph in radians. Instead of using on the x-axis degrees, we could use radians, and we could redraw it in radians. You'd see it's exactly the same graph, but we're just utilizing radians on the x-axis instead of degrees. For this example, nothing's changed apart from talking about the period. Instead of the period being 360 degrees, the period is now referred to as 2 pi. 2 pi radians is the period of the sine graph when we're talking in radians. Okay, let's turn our attention to our second example, the cosine graph, y equals cosine of x. Here's what the y equal to cosine function looks like. Very similar to the sine function. Again, you'll notice it does not pass or go greater than 1 and less than negative 1. So we refer to this word as the amplitude, and the amplitude of the cosine graph is also 1, the same as the sine graph. This time, however, the cosine doesn't start at the origin, it starts at the point 0, 1. So that's a slight difference to the sine graph. And you can see that the period of the function, the one part of the graph that repeats itself over and over, is the same, it's 360 degrees. Now again, we can draw the cosine graph in radians. Instead of degrees on the x-axis, we could change it into radians. Everything looks the same apart from us talking about the period now. It is in 2 pi instead of 360 degrees. Right, well our third and last graph is called the tan graph, y equals tan of x. Here's what the tan graph looks like. It is completely different to the sine and cosine graph. Now we have these vertical lines which are called asymptotes. These lines are where the graph will get close to but will never touch. If I take the tan of 90 or 270 or 450, I will get an error. So there's no such value for tan of 90. Right, well this graph again has a period, and it has a period of 180 degrees, not like the sine and cosine, which is 360. If I was to redraw this into radians, we refer to the period as just pi radians. Right, well that's us. Thanks very much for watching.